This is a complicated puzzle, but if we just take our time and go slow and do one piece at a time, focus only on that piece, and not worry about any other pieces other than the one that we're working on, then we can get through this relatively stress-free. It's the same idea as thinking about building a house. That would seem overwhelming because it's so complicated, but a builder only has to worry about laying down one brick at a time, and the framer only has to worry about putting in one nail at a time. And millions of houses are built and nobody's overwhelmed. It's even similar to thinking about getting a high school degree. If you tell somebody you want to do something, but it'll take 12 years to do it, that is a huge amount of work, and that's complicated, and that could seem overwhelming. I mean, it's 12 years of work, yet everybody does it because you just do it one day at a time. So that's what I'm going to do here. Just one puzzle piece at a time. So this is how you prove that throwing an object up or shooting a ball out of a cannon at 45 degrees is the optimal angle to get the farthest distance. I only had a couple of semesters of intro physics when I was in college, but I liked physics a lot, so I did what I think a lot of other people did. When I learned about these kinematic equations and we were told that a 45-degree angle will give you the farthest distance if you're going to throw an object, I started plugging numbers into the equations. I would do like 44 degrees, 45, 46. But after all my calculations, I always turned out with something like 45.5 degrees or 46 degrees or 44 degrees to yield the farthest distance. And I can never get 45 degrees, and the reason is you have to do 5 steps to solve this problem, or 5 equations. You do one equation and get a number, and then you plug that number into another equation and get another number, and then you plug that number into another equation and get another number. And after 5 steps, you're always going to have to round because you're always going to end up with a number with infinite numbers after the decimal place. And rounding each time on all 5 of those steps is going to give you quite a bit different number at the end. So what we do to avoid all that is we just plug one equation into another and then plug that equation into another and actually don't use any numbers, we just use the equations. And then we end up with a 45-degree angle, or pi over 4, as our optimal angle to yield the longest distance. For this puzzle here, you just need the basic trig, which is required to take physics classes typically. And at the end, there's a little bit of introductory calc. I like the idea of keeping my channel self-contained, or somewhat self-contained, meaning that if I'm covering something sort of complicated here, you can look back at my other videos and learn about those, and then you could understand this video. So I did some videos on basic trig and basic calc. Okay, I'm gonna do this super simple and intuitive, then that way we can really get an intuition of what's going on instead of just blindly plugging in numbers. This is complicated enough, I'll admit. The first time I did this, just one equation led to the next, and that equation led to another. So I'm just plugging equations into each other left and right. And it was kind of like one of those cartoons where there's a roller coaster going up and down and somebody's hanging on the back of that roller coaster flapping in the wind. And they're just trying to hang on for the ride. And then at the end, they get to their destination, but they're not really sure how they got there. And that's what happened to me the first time I did this. So this time I'm going to slow it down and make it intuitive and go really slow so we understand each step. So first off, let's say we have a lightweight ball we're going to throw up in the air. Maybe it's a tennis ball. Maybe it's some sort of just little plastic hollow ball. And there's a big fan blowing to the right. And so we're going to throw this ball up in the air in front of that fan. The higher the velocity we throw that ball up in the air with, then the more distance that ball is going to go in the y direction. And thus, the more time it'll spin in the air. And since we're throwing this ball straight up and down, but it's in front of a fan, it's going to be blown in the x direction. So the more time it spins in the air, then the farther it will go in the x direction. So that's exactly what I'm doing here. Just look at your kinematic equations. First, I solve for velocity in the y direction, and then I solve for distance in the y direction, and then I turn that into time, and then I turn that into distance in the x direction. So first kinematic, v final squared in the y direction equals v initial squared in the y direction plus 2 gd. I'm using g for acceleration for gravity. To make this simple, all we do is throw the ball straight up in the air and let it hang there and come back down. Let's just pretend that the fan's turned off, so the ball is just going to go straight up and straight down, so we just want the amount of time that that ball is in the air. Or sorry, we want the amount of distance that ball is going to cover going up, and then we turn that into time. So first off, we need to get our velocity in the y direction, and then we can determine our distance. Let's say that the final velocity is 0, because as we throw that ball straight up in the air, it's going to hang there at the very top for an infinitesimally small amount of time before it comes back down. So final velocity will be 0, and the initial velocity is what we throw the ball with. That initial velocity, we get this with our first calculation. Velocity right here, we got velocity in the x direction, velocity in the y direction. Sine theta equals vy over v. So we take v sine theta to get velocity in the y direction right there. Now we can plug this v sine theta up here into our equation. Move this down right here. Here I just showed an example. We have a cannon shooting a cannonball out, but it's not shooting it straight up. It's at some angle. Also, FYI tip I think is interesting. When explaining this velocity in the x direction and y direction to people, I think it's best to think of these as the shadow velocity. So you have a ball traveling that we're throwing up in the air in this direction. We have a spotlight shining straight down on it, and that spotlight is going to create a shadow. And so that the shadow of that ball is going to move along here with a certain velocity, and that is the velocity in the x direction. And likewise, we have another spotlight shining on that ball in that direction. So we're going to have a shadow for that ball that represents velocity in the y direction. So you can imagine if this is a really steep angle, this ball is going to travel super fast going up, but its shadow is going to travel really slow because the ball is mostly going up instead of in the x direction. And another way to explain this is, the ball has to travel a very long distance across the hypotenuse of this triangle, but its shadow is going to travel a very short distance. They're trying to make it look a little better. But they both have to reach their destination at the same time, thus the shadow of the ball is going to travel very slow. And it will have a very slow velocity in the x direction because the ball is being shot up at such a high angle. Okay, so I go down here now. For the velocity right here, I plug in v sine theta because we want velocity in the y direction. We're going to pretend we're just throwing this ball straight up and let it come straight down. Minus 2gd, that's a minus because acceleration from gravity is negative, pulling it down. So now we have 2gd equals v sine theta, quantity squared. I rewrote it right here. Let's solve for distance in the y direction, so we get this. So now we know how high that ball is going to go when we throw it straight up in the air. That's all we need to know for that first step. Next, we need to find the amount of time that ball will be in the air, because when we throw this ball across a football field or a baseball field or whatever, the longer that ball is in the air, then the farther distance it will travel. Thus, we need the time that that ball is in the air. So we use this equation right here, 1/2 gt squared equals distance. And this is actually distance in the y direction. So we take our distance in the y direction, plug it in right down here. Now what we're solving for here is, we've already thrown this ball up in the air, so now it's hanging there and not moving at all. We need to know how much time it's going to take for this ball to fall from its highest peak down to the ground. And that will give us time. But then we need to multiply that time by 2, because when we throw that ball across the field, there'll be a certain amount of time for that ball to go up in the air, and then a certain amount of time for that ball to come down in the air, and those times will be equal if we ignore air resistance. And next page. Watch what happens here when I substitute this dy right here, all of this, and for right here, we get this right here. I need to go ahead and isolate t, so I bring the 2 over here and put it in the numerator, and bring the g down here. I just spotted another error that I'm going to correct. Like I previously said, this is a very complicated puzzle, and this leads to many opportunities to make an error. Okay, what I'm doing here, I'm just have the ball up here in the air and I'm going to let it drop. Distance has to be negative because the ball is falling. And gravity right here will be negative also because it accelerates the ball down. So what happens here is we have a negative divided by negative. Go ahead and isolate your t right there. When I previously did this problem, I couldn't find my error, and thus I thought I didn't make one, but I couldn't figure out why I was ending up with a negative time. And that's not possible unless you're a time traveler, meaning you're going backwards in time. So my error was right here, this had to be negative, so I'm dividing a negative by a negative to get a positive time. And the world makes sense again. So, oh, I forgot right here, I didn't highlight. I put a bunch of stars here because I really wanted to highlight this. The first equation here, we solve for distance up. And so that's the first step. That's important. We need to know how high that ball is going up in the air because, like I said, the higher it is, then the more time it'll spend in the air. So we use that distance right there to solve for time right here, and I'll show the next page. Like I said, I want to go really slow and make this really intuitive, and I want to do that for two reasons. First off, this is extremely complicated, and there are a lot of potential opportunities to make an error. So we really need to go slow and take our time to avoid those errors if possible. And secondly, by going really slow, we can really get an intuitive feel or an intuition of what's going on. Instead of just blindly plugging numbers into equations or blindly plugging one equation into another and then into another, I really want to make it slow and intuitive. Okay, so enough with that. We solve for time. It's right here. I just went through the equations. And now we have time for the ball to go up and time for the ball to go down. So we multiply by 2. And that's what that 2 is right there. Whatever number we get for time, multiply by 2, and we will have the total time in the air. I drew a box around this. I put a number 2 here because this is the second important thing that we've solved for. The first one was distance. Now we solve for time in the air. Now that we have time, this is where it gets simple. We just do distance over time equals velocity. But we need velocity in the x direction. So if this was just a Corvette or something that we were driving down the highway, we would just have one velocity. But since we're throwing this ball up in the air, we have to divide this up into a velocity in the x direction and a velocity in the y direction. In other words, we need to know how fast the shadow of this ball is traveling along the ground. If we were to shine a light straight down on it while it's traveling up and down. When that ball hits the ground, the trip is over. So we need the velocity of the shadow of that ball as that shadow travels along the ground until the trip is over. Okay, cos theta equals adjacent over height. That's velocity in the x direction over velocity. Thus, v cos theta equals velocity in the x direction. Now, since distance over time equals velocity, this means that velocity times time equals distance. And I'll use this equation next. Okay, velocity times time equals distance. Velocity in the x direction is v cos theta. Time is on our side. As Azazel said in the movie Fallen with Denzel Washington, that was a good movie. So time is v sine theta over g times 2 right there. And what do you know? I forgot my 2 right here. I'll just put the 2 out here. There we go, because I have to multiply time times 2. Now let's clean this equation up and organize it. Let's pull out the velocities, the g and the 2 right here. And right here, this is the meat and potatoes, or this is really the only part of the equation that matters. Cos theta times sine theta equals distance in the x direction. Take all of this stuff over here and turn that into c for constant. So yeah, I know I did not need to add that 2 there, but I still needed to add it just to be complete, to show that I know what I'm doing and make sure I know what I'm doing. It's usually not good to be sloppy. Now if you graph out cos theta times sine theta right here, you will get a sine wave. I just spotted another error. This extra right here is a 0.5. It's not 1. So what we have here is angle on the x-axis. That is our independent variable. We're going to change the angle of our gun. And on the y-axis, we have our dependent variable, which will be distance in the x direction. So when we graph this out, we start with an angle of 0 degrees. The barrel of the cannon is right at dirt level or ground level. So sine of 0 equals 0. So this equation will equal 0. So the cannonball will come out and immediately hit the dirt and cover no distance. Then we gradually raise the angle or increase the angle of that cannon barrel. When this cannon angle is up to pi over 2 or 90 degrees, the cannonball will go straight up and then come straight down and cover no distance in the x direction. Cos of pi over 2 equals 0, so this equation right here will equal 0 distance in the x direction. You can find out your peak here in 3 ways. One way is to plug in a bunch of numbers at pi over 4 and around pi over 4, and you'll find out that pi over 4 gives you the highest distance in the x direction. Or you can use your graphing calculator. Just plug this equation into the graphing calculator, and the graphing calculator will give you the coordinates of pi over 4, 0.5 as your peak. And the third option is to use calculus, because calculus will give you an equation for the slope of a line at a point. So we set slope equal to 0 because we want the highest point right here where the line is neither going up nor down. And I'll show that on the next page. Okay, right here, theta is on the x-axis. The distance in the x direction is on the y-axis, but we're not going to graph out theta and distance in the x direction. We are going to graph out theta and the slope. So if we were to make another graph, we would graph this out as theta on the x-axis, and then the y-axis would be our slope. So we're going to set slope equal to 0. Take the derivative of sine theta cos theta. This is just a double angle, so you have to look that up if you don't have it memorized. So sine theta cos theta, derivative of that is cos 2 theta, that equals 0. By the way, in your graphing calculator, you can type in cos 2 theta and look at that graph. And you'll see that when x equals pi over 4, y will equal 0, and it will form a sine wave. So I thought that was kind of fun. But that's actually what we're doing right here. Like I said before, I really strive for the deepest level of understanding. But back to this cos 2 theta equals 0. This was a bit of a head scratcher. I had to look at this for a couple of minutes to figure out what to do next. I knew it looked familiar, and I realized that cos of pi over 2 equals 0. So therefore, since cos 2 theta equals 0, cos pi over 2 equals 0, they both equal the same thing. I can set cos 2 theta equal to cos pi over 2, and it looks like this. This shows that 2 theta will equal pi over 2. The logic is, I'll show a little tangent right here. If we have 3 to the x equals 3 to the y, then for example, if x equals 2, this would be 3 squared. This will have to equal 3 squared. It cannot equal anything else. Therefore, x equals y. So here we have 2 theta equals pi over 2, divide by 2, and we get theta equals pi over 4, or 45 degrees. This is where the slope of our line right here equals 0, and this is the highest point on the curve. And this shows us that an angle of pi over 4, or 45 degrees, will yield the farthest distance of a projectile in the x direction. So I'll do some bonus insights now. This long, complicated puzzle had a lot of pieces and, I don't know, 10s or 100 different opportunities to make an error. But every step was actually really simple and just basic trig and basic physics and basic algebra. So I tried to go really slow to make it intuitive, even though I didn't have to do that. But I found out when I used to tutor people, like I said before, I never charged for it. I just did it for fun, for friends to help them out. I found out that there is a narrow teaching window where you can teach somebody something. If you talk above them, then they won't understand. If you talk below them or teach below that, then they'll be bored. But if they're a little bit bored, they can still learn the material or learn whatever material that they don't already know. But if you're teaching above their level, then they simply can't learn the material and you're wasting all your time. So I found out it's safer to teach a little bit below people's level, and that way you can catch everybody and be most inclusive, or include the most number of people that can learn from whatever it is that you're teaching. So that was a pedagogical point. Pedagogy, or pedagogy, that is just the philosophy of teaching. Also, while this puzzle seemed very long and complicated, I could actually break it down and make it appear very simple and show all the steps that we just did. And by the way, every step would be a rounding error if you actually plugged in numbers to try to solve this. The first step was we solved for velocity in the y direction. That makes sense because the faster we throw something up in the air, then the higher it goes and the longer it'll be up there. So we solve for velocity in the y direction to get our distance, and then we use distance to get our time. And then we had to multiply that time by 2 to include time for travel going up and time for travel coming down. Then we had to get velocity in the x direction, and then we had to get distance in the x direction. So 5 separate steps, but each one individually is very logical and simple when you think about it and just isolate that individual step.